so now I'd like to talk about soil vapor extraction. And basically soil vapor extraction is related to soil vacuum extraction. But for the soil vapor extraction, what we're going to do is put pipes into the ground and into the vadose, the area right above the water table. And we're going to inject air, and what happens is the contamination is going to float up to the surface where it's can be more easily reached. Now lastly, and my favorite, we're going to talk about ozone sparging. Alright, ozone sparging is the treatment method that they used on the site where I went to take my samples. And so it's kind of a new technology, which is why it's so interesting. Now we know what happens in the lab when we expose bacteria and different things to the ozone. Basically, the ozone will kill whatever's there, whatever is in its presence. It will just be decimated within a matter of minutes. It doesn't take long at all. What happens on site for a leaking underground storage tank site is they'll bring in a trailer onto the site, and they'll make their ozone right there. So they'll have an oxygen tank, and oxygen is O2, right? And then they're going to force the oxygen through extremely high voltage, and it's going to cause some of the oxygen molecules to split and recombine to make O3, which is ozone. And then they're going to pump the ozone into the ground, and just volatilizes the contaminants. It totally eats them away. So we think that that's a really good idea because you're talking about minimal equipment. It's minimally invasive. You're talking about oxygen and electricity. Sounds pretty good, we think. All right, so it is being used without too much research in the area of environmental remediation, but ozone is widely accepted in the use of in the food industry. So next time you go to Walmart and you pick up that big red delicious apple and you look at it, yummy. It may have been treated with ozone. So what happens is they're going to put your food onto a conveyor belt, and they're going to send the conveyor belt through a large machine, and it's going to expose the food to ozone, and it's going to kill the bacteria, we think. What we can test anyway. And ozone is becoming useful in wastewater treatment as well, but we're still kind of testing it out in that area because most new developments happen outside of town, so it becomes a cost-benefit analysis. Is it effective? Is it cheap to get electricity? And can we sort of hide this ozone tank and all? All right, so sampling methods. What happens after we think that there might be a leak in our underground storage tank? Well, we'll call an engineering firm, and they're going to bring out something that looks a lot like this. This is called a geoprobe, right? And what happens is the geoprobe has a long arm, and on the end of that arm, we've got about a 3-foot tube, and they'll force the tube into the ground, and they'll pull it out, and what you get is a nice, what we call a core sample. And then, they'll just do that repeatedly. So you've got 6 feet, you've got 9 feet, you've got 12 feet, and we'll go usually to right above the water table. This is the method that they used whenever I was taking my samples. And right here you can kind of see an outline of the plastic tube that I'm talking about. So it's pretty thin, and we've got a really nice looking core. It filled up the whole tube. All right, then, they'll take their samples back to the lab and analyze them, and see exactly if there is contamination or not, and what it's contaminated with. And what I did for my experiment after I got my samples was called DNA extraction, and I bought a kit that looks a lot like this one down here, which basically removes the humic acid from the soil or the dirt, and it just left me with the DNA in my test tube. So that's what I wanted, just the DNA. All right. And then after I did my DNA extraction, I did what's called polymerase chain reaction, or PCR. This is a picture of a PCR machine, and what you're going to do is, that lid lifts up and you put your sample in there, and you expose your sample to time and temperature, and a reaction occurs. We've all had experience with polymerase chain reaction. Next time you're watching CSI and they're doing a DNA test with a hair sample and whodunit kind of thing, or you're watching Jerry Springer and they're trying to figure out baby daddy and that kind of thing. So we've all had some kind of experience with PCR. And what happens in your test tube, after you've done your DNA extraction, you're going to take your primers, or basically all primers is a sequence of DNA that the scientist wants replicated from their sample tube. So you send this sequence off to the lab, and they'll give you your tube back, and it's going to have your primer in it, and it's going to have different polymerases in it, so that you can undergo this PCR reaction. So what happens exactly in PCR? We've all heard about DNA and the famous double helix. We all know about that. So the double helix unwinds, and then it starts to denature when the PCR machine gets up to around 95 degrees. Right? Denature just means that the two strands are going to separate. So we've got a 3' and a 5' end, and then at the top, and then at the bottom we've got a 5' and a 3'. So your primers, during the annealing phase, are going to attach to the 3' end, right? And then what happens after they attach is Taq polymerase comes in during the extension phase and pulls, an A to it, and pulls a T to it, etc., until you've got your complete extension. Now, every cycle, you're talking about an increase to the second power. So at the end of your PCR reaction, you've got a lot of the DNA that you want, that you're looking for based on your primer in your test tube. So that's really nice. It's cheap, it's simple. It really, in the scheme of things, doesn't take long